Hey everyone, it's Mrs. Brumbo, and today we're going to take a look at linear versus nonlinear functions. So for the last few days and in our previous unit, we really focused on linear functions or linear equations. So now we're going to take a look at what do nonlinear functions look like and how do they compare to our linear ones. So we're going to start by doing an investigation. So directions: go to Desmos, which is a free graphing website, graphing calculator. And then I'm going to show you how you can input these functions, or maybe not, and see what they look like on the graph. So, desmos.com. So when you get to this website, you're going to click Graphing Calculator, and it's going to take you to something that looks like this. So on your sheet, you have a list of equations that you're going to type in, and you can type in more than one equation. So over to the left is where you're going to type in your equations. So y equals x is our first equation, and that's in red. My next equation is y equals x squared, so y equals x. Now, when you go to type in an exponent, you do shift 6 at the same time. So once again, shift 6 at the same time, then you type in your exponent. You're going to notice it's going to pop up on your graph as well as your first one, and you can start looking at them, comparing them. So you're going to finish putting the rest of yours in. The only other one I want to show you how to do is y equals the last one, which is the absolute value. So right here at the bottom left corner, there's a keyboard that you can use. And over here, it has the absolute value bars with an A in the middle. And then you can just type in X and then click out of it, and it should graph it for you. Okay. So let me move my stuff around so you can kind of see. So you're going to graph all these equations. It gives them different colors, and then you're going to go through and answer the questions. So I want you to pause to do that right now, and then when you're all set, you can come back. Okay. All right, so I'm just going to finish graphing these equations so that we can go back and forth and comparing them. All right, so we've got all of our equations. Now, if you want to focus on a specific one, you just click on it and it makes it a little bit bolder. It might be a little hard to see. So the first question says, are all of the equations you graphed on Desmos functions? So basically, would they pass the vertical line test? And the answer is yes, they are all functions. Y equals x is a linear function or a linear equation. Y equals x squared, that's our u, that's in blue, and that would pass the vertical line test. Y equals the absolute value of x looks like the v, it's green for me, that would pass the vertical line test. Y equals 2x cubed, so that's in black for me. It's got the little curve here, but that would still pass. Y equals 4x minus 3. That's the second red line I have. That's starting down here. That would. And y equals 1 over x. So it looks like they might be coming close together, but it actually won't touch the axis, so there wouldn't be any overlap. So this would be a function as well. So I'm going to be flipping back and forth a little bit. So pause as needed. So yes, they are functions because they would all pass the vertical line test. And I'm just going to shorthand that. Okay. Which equations would be considered linear? So remember, the word linear means line. So we're looking for a straight line from top to bottom. So y equals x in red, as well as my other red equation, y equals 4x minus 3. Those are the only two that are straight lines. So coming back here, y equals x and y equals 4x minus 3. The rest, even though I want to point out the green one for me, which is the V shape, even though it uses straight lines, it's not one continuous straight line, so that wouldn't be considered linear, okay? Excuse me. Taking a look at the next one, What is the difference between the graphs of linear functions and nonlinear functions? So for me, the two linear ones are in red. So those are continuous straight lines. However, y equals x squared has a curved, and the absolute value of x in green, it doesn't have a curve, but it has a point where it turns. 2x to the power of 3 and 1 over x. So all of them have a curve or they aren't a perfectly straight line. That is the difference. So they have a curve or not continuous straight line for nonlinear functions. And then if we compare those equations, so once again, in red, we have 4x minus 3 and y equals x. Well, two of them have exponents, and then two of them are using other operations other than multiplication, addition, and subtraction. So that would be the difference in the equations. So nonlinear functions use exponents or other math operations. And I'm just going to list them here. So y equals x squared. Put this up a little bit. We had y equals 2x cubed, y equals 1 over x, and y equals absolute value of x. Then sketch a graph of a relation that is not a function. So there are so many examples you could do. For example, you could draw a nice little heart. It overlaps. You could draw a massive circle. I'm going to use a different color. You could draw a sideways U. You could draw a sideways V. Anywhere where the graph is going to hit, your vertical line is going to hit the graph at more than one space, meaning it shares multiple x values, makes this so it's not a function. Okay. So to summarize what we've seen in this investigation, if you go to today's Canvas lesson, I've posted a PDF summarizing this information. So I would print this out or make sure to get a copy when you come back to class. So as a graph, linear is a straight line and nonlinear is curved or jagged. Okay. In a table, it would have a constant rate of change to be linear. That's what makes it so it has the constant rate and makes it linear. And it would not be constant if I was looking at a table that was nonlinear. For your equations, they will look something like this, where you don't have any exponents, versus this where you do have exponents. So those are the things to look at. So this is a really nice sheet, like I said, bringing all this information together. So now you're going to work on iExcel for at least 15 minutes if you're at home, or up until you earn a 100 SMART score, whatever you learn, get to first. And if you have any questions, let me know. Thanks.